In this problem, we are given that in triangle ABC, AD is perpendicular to BC. Angle BAD equals to 15 degrees. Angle B equals to 75 degrees. AD equals to A. BC equals to 2A. Find the measure of angle C. Notice that since AD is perpendicular to BC, triangle ADC is a right triangle. To find the measure of angle C, since we are not given any other angle, like CAD for example, we have to resort to the side length to help us find the measure of angle C. This means that we should first try to represent CD in terms of A to see that if the ratios between the three sides of triangle CAD are in a special proportion, such that triangle CAD is a special right triangle. So to find CD, we need to first find BD, because BD is easier to find since BAD and angle B are both given angles. How do we find BD in terms of A though? To find side lengths, we notice that 75 degrees minus 15 degrees is 60 degrees. 60 degrees is a special angle in right triangles. So we have to find 15 degrees in the 75 degree angle by constructing it. First, if we construct an isosceles triangle, how do we find the point such that we can find the other leg of an isosceles triangle with AB as the longest side? We know that in isosceles triangles, they have a property that their height and angle bisector and the median are called the 3 and 1 line because they overlap. So if you draw a triangle PQR and then let PS be in the 3 and 1 line, then PS equals to SR. PS is perpendicular to QR. PS is the angle bisector of angle QPR. So if you wanted to construct an isosceles triangle, we could first construct the 3 and 1 line. We can't find the angle bisector of any angles yet, so we can first try to find the perpendicular bisector, which is it bisects AB and is perpendicular to AB. So we can call the midpoint of AB as E. Then construct the perpendicular bisector. So AE will equal to BE. Then we can call this point where the perpendicular bisector intersects with AD as F. Then we can connect BF. So first, we constructed perpendicular bisector FE. Then connect BF. Now, we have to prove that triangle ABF is an isosceles triangle using the fact that FE is a perpendicular bisector. So we need to prove that AF equals to BF. We can do this by congruent triangles. So since AE equals to BE, angle AEF equals to angle BEF equals to 90 degrees, and then FE equals to FE. So triangle AEF, congruent to triangle BEF by SAS congruence. This will mean that AF equals to BF, and angle EBF will equal to angle EAF equals to 15 degrees. So this will mean that angle FBD equals to 75 degrees minus 15 degrees equals to 60 degrees. Since angle FDB equals to 90 degrees, so angle BFD equals to 30 degrees. So we have triangle BDF is 30, 60, 90 right triangle. Now we can use the proportions in a 30, 60, 90 right triangle. First, we can let BD equal to X. So by the proportions in a 30, 60, 90 right triangle, BF will equal to 2X, DF equals to square root 3X. And then we have AF equals to BF by the isosceles triangle, and this will equal to 2X. So AF equals to 2X, and then DF equals to square root 3X. We know that AD equals to A, so 2X plus square root 3X. You can factor out the X, so it'll be X times 2 plus square root 3 equals to A. So X equals to A over 2 plus square root 3. You can simplify that by rationalizing the denominator. That will equal to 2 minus square root 3A. This will equal to A over 2 plus square root 3 times 2 minus square root 3, 2 minus square root 3. So notice that it'll be 2 minus square root 3A. The bottom is the difference of squares, which is 4 minus 3, which is 1. So that's how you get 2 minus square root 3A. And then DF is square root 3X. But now that we know BD, we can get that CD equals to 2A minus 2 minus square root 3A. So CD equals to square root 3A. And then we notice that since AD equals to A, CD equals to square root 3A, this satisfies the ratios in a 30, 60, 90 right triangle. So triangle ADC is 30, 60, 90 right triangle. So angle C equals to 30 degrees. That is how you solve this problem.